pierce a hole in the earth, what happens when you jump in from one end? Will it stay in the center, or will it emerge from the other end? What would be your answer? Today, together, we will set foot on a journey through space, visual journey. We're in intergalactic space, billions and billions of kilometers away from the Earth. We are lost between two nearby galaxies, our own Milky Way and Andromeda Galaxy, another galaxy composed of hundreds of billions of stars. All around us, space is almost completely empty. Despite this, we're not going nowhere. A web is woven around us. It's the web of the universe itself. Space-time, this imaginary grid of tiny particles, will enable us to visualize the invisible, the geometry of the universe, and understand its dynamics from where we are. The grid is calm. Still, nothing could disturb him. If we drop a marble, he's going to fly straight ahead, forever through the void. In fact, the grid is not completely static. If we accountant, we will see it drift very slightly, like a river flowing to the stars. Its flow carries all the stars, gas clouds and dark matter, effectively distorting space-time, pulling the fabric of the universe in their direction. Very slowly, the two galaxies are getting closer. Billions of years later, long after we disappeared, the Milky Way and Andromeda will eventually merge, become one. Although Andromeda is getting closer, but in the early 20th century, researchers found that most galaxies, it actually moves as one unit. The universe is expanding. It's like a stretched piece of fabric. It's getting bigger and bigger, and take galaxies away from each other. As this expansion progresses, their wavelengths of light are stretched and turned red. We know today that this expansion, it's accelerating, stimulated by mysterious dark energy. Expansion may have started 13.8 billion years ago. Extreme compression contains only a cloud of fluctuating energy. The universe will suddenly fall, reach astronomical size in a fraction of a second. This is the Big Bang. What did no one really know until then? Tiny fluctuations become huge, attracts matter and condenses it into a filament. Halo, then galaxies and Earth. We live on a star called the Sun. Multiple celestial bodies orbiting the Sun near a star, planets, asteroids, and comets. It moves freely through the grid of the universe. The Sun's massive mass is the curvature of space-time, fabric falling to the stars. Take everything away. This is how the planets orbit. Without moving too far from the Sun, they're going straight ahead, but the constant flow pulls them back to the center. To a lesser extent, planets also attract the webs of the universe. The grid is headed in their direction, so the Earth is pulling on its natural satellite. The Moon and all our satellites. The International Space Station travels through time in a straight line, but space-time is curved by the Earth. Keep him away. At a sufficient distance, the grid is slow. A fast-moving object. It will not be difficult to escape this curved space, but as we get closer to the center, the flow gets denser, the faster the grid gets. On the surface of our planet, the rocket must reach a very high speed to take off from the ground and escape the Earth. Grid converges to the center. If we drop a few apples side by side, space-time will gather them in one direction and stretch them in the other direction. That's called the tidal force. This is the same effect the Moon exerts on the Earth. causing the movement of water on its surface. The back and forth motion of the tides is caused by the rotation of the Earth itself. He will be in about 24 hours. Rotate once. This motion of all masses affects spacetime and very slightly drag the grid. When we drop an apple, even if he doesn't touch the Earth, the rotation of our planet also affects him from a distance and slightly bend his trajectory and direction. Inside the Earth, the grid continues to fall down. He tried to bring everything to the center. The materials that make up our planet are resistant, ability to compress. They exert tremendous outward pressure, so as not to collapse. This is when we jumped and landed. The pressure felt on the legs. In the center, the rivers converge. If a marble, capable of withstanding the intense pressure of the Earth's core, he will remain there motionless. All grains reaching the center, the child continues to advance and rebound until they re-emerge from the Earth. Remember the question at the beginning of the video? The answer is that if we could travel across the entire planet, we'll come out the other side. In 5 billion years, our stars will eventually die. The sun will no longer be able to generate its pressure and resist the flow of the grid. His core will collapse like itself, forming an extremely dense white dwarf. And its atmosphere will slow down, expanding into a giant planetary nebula. However, not all stars disappear this way. Hundreds of light years away, another star, a supergiant, is also burning. Its final fuel is 20 times more powerful than the sun. Its internal pressure can no longer support its weight. Nuclear. Heart collapse outer layer rebound. Explode into a supernova. Core is compressed more and more until a neutron star is formed. It contains the mass of 2 suns, only within 30 kilometers of space. The cosmic grid is stretched so far, so much so that light itself is dragged around, creates strange light and snow muscle changes. Thousands of light years away, another, bigger star is about to explode. Moment. The core is brought to the center and the outer layers are violently blown away. This time the universe is stronger. He drags the core of the star towards the center. All the mass is condensed in a small sphere. The universe is so curved that its plants are falling faster than the speed of light. Nothing can escape. Take off this hellish treadmill. Everything is brought down. Can't even stay still or send a signal. It's a black hole. In the universe, some black holes are born near another star. They don't get the substance, in the form of plasma at very high temperatures, into the orbit of the black hole. The plasma forms a strike disk, losing energy and spiraling towards the interior of the horizon, very close to the center of the black hole. Flow becomes infinitely fast. All objects are killed violently. The Admiral grid stretched so violently, so as to separate atoms from each other. And that's what elongates everything. In our current theory, not enough to describe the quantum behavior of space, the center of rotation. Black holes. Nothing in the universe is static. All stars rotate to some extent. When they die, when their cores compressed to form black holes, their rotation accelerates, like a pin skater with folded arms. This rotation is imprinted on the plant of spacetime, continues to spin even after the black hole, in what we call the Argus of a black hole. Within a certain distance below, the entire grid is carried into a superluminal vortex. This causes the object to rotate in the same direction. Even light is forced to spin with the black hole, below the horizon. The grid is falling faster than the speed of light. Such a black hole would have an internal horizon, which consists of time and space. The centrifugal force generated by the rotation counteracts the gravity and slows the descent of the grid. Mathematics expands these internal horizons, extend to the point where we can, the white hole that emerges from it, to explore parallel universes. However, the internal horizon of a black hole is extremely unstable, may not exist. The central structure of a real black hole remains largely unchanged. Finally, if two black holes meet, they can start dancing, pull each other faster and faster, until they merged and forming a much larger black hole. This new black hole vibrates like a bubble. It stabilizes. In such an event, the fabric of the entire universe is driven by vibrations, forming more stars than all observable stars, more attractive force, and escape at the speed of light, distort everything in their path. September 14, 2015. After more than 1 billion years of travel, one of these vibrations eventually passed through the Earth. In an instant, the Earth is shaken by a fraction the size of an atom. But for the first time in history, researchers have detectors to measure these earthquakes. Moved them to witness more than 1 billion years ago. It was catastrophic. Integration in 2015. A whole new field of astronomy was thus opened up. Attractive force wave astronomy allows us to explore even more extreme structures. Thanks for watching.